Okay, this is going to be our last video with radicals. And what we're going to be doing is solving radical equations, okay? So, we're going to take a look at these, and basically when we're looking at these radical equations, we're going to apply kind of the opposite of the square root property, all right? Our first example is this. We have 9x plus 7, square root 9x plus 7, within the radical sign, plus 5, which is, as you can see, outside of the radical sign, equals 1. Okay? Now, the thing that we need to consider is that in order to solve for the variable, we have to get rid of this radical sign. The inverse operation of square rooting something is squaring it. Okay? So, if we can move our 5 to the other side of the equal sign. Okay, now we'll have square root of 9x plus 7 equals negative 4. Okay, so now the only thing on the left side of the equation is the radical. On the right side of the equation, we have a negative 4. Now we said that in order to get rid of this radical, that we can square this. Now if we square the left side of the equation, we also have to square the right side, okay? Which means that now on the left side, we have 9x plus 7. That's going to be equal to negative 4 squared, which is 16, okay? Now this looks like we might be on the right track. Okay, we'll subtract 7, and we have 9x equals 9. That's convenient. I'm going to rewrite that over here. 9x equals 9. We'll divide by 9 on both sides. X equals 1. Okay. All right, let's take a look. We have 2 more examples to go through here. Okay, here's another example similar to the last one. We have the radical sign on the far left. Then we have a plus 7 here, and that's set equal to 3. Okay, now the first thing we want to do is get this radical by itself on one side of the equation. So we'll subtract 7. Okay, now we have square root of 5x minus 7 equals, oh, look at this. Again, we have equals negative 4. Okay, we'll square both sides here. And we have 5x minus 7 equals 16. Okay, this time we're going to add 7. Okay. Ooh, this one's not going to be quite as pretty. Okay, so we have 5x equals 4, 3, 23. All right. Now we'll divide by 5. And x equals 23/5. Okay. Now if you get a fraction, we can just leave it as a fraction like that. That's okay for our purposes. It's more the matter of the process that we go through to get rid of the radical and solve for the variable. Okay? All right. Let's take a look at one more. I kind of want to, move this out of the way a little bit so we can not be distracted. Okay, so this last one here. Here we have an equation with 2 radicals. Everything that's within this equation is part of one of the radicals, okay? Now the same rule still applies, that if we see a radical, we know that in order to get rid of the radical, that we need to square what we have here, okay? So if we square one side, we square the other side. So now what we're left with is 3k plus 1 equals 2k plus 6. All the radical signs are gone. Okay, now it's simply a matter of combining like terms. Minus 2k and minus 1, minus 1. So now we have k. 3k minus 2k is 1k, or k. K equals 6 minus 1, 5. Okay, so it looks a little bit intimidating at the beginning, but if you have your radicals alone on one side of the equation, then you can just square them. okay, in order to get rid of the radical.